Okay, now in chapter 2, the Altibase HTTP features. In this chapter, we'll talk about what are the functions that Altibase HTTP provides, and then functions that Altibase HTTP does not provide. Okay, the most of disk DBMS has multi-process architecture, but Altibase HTTP has multi-thread architecture. Okay, that is one process with multiple thread. It is a relational DBMS. Also, it is client and server architecture. Altibase HTTP provides 3 different connection types. They are TCP/IP, Unix Domain Socket, and IPC, the inter-process communication. In Altibase HTTP, the connection type is TCP/IP on default. Okay. For HA, Altibase provides replication. Replication is basically sending a data from local server to a remote server through a network. All the servers are separated and they do not share single storage like RAC, which means that each server has its own storage and schema. So it is share nothing architecture. So it is basically replicating a data from one server to another. And also one server can be connected with 32 servers up to maximum. It is data cloning, not data sharing. It is table-based, which means that we can choose the specific table for replication, and also we can remove the table from the replication list. So it is done by table unit. So when you firstly create replication object, you need to assign the tables as well, the tables you're going to use for replication. Okay. We support 64-bit and also 32-bit as well. For CPU, we support Little Endian and Big Endian. Also, Altibase HTTP support various operating systems like Sun, HP, Linux, Windows, and etc. Okay, we support table and row level locking. That is basically MVCC. Okay, some of you may know what it is, but the MVCC stands for multi-version concurrence control, and what it basically does is that it creates new versions of data every time the data is updated, so that when one statement executes DML on a certain data, the other statement can also execute the same data as well by accessing the different version but the same data. So we do support MVCC just like other DBMS has, but the difference is that we support MVCC for memory and a disk separately. I'll explain about this in more detail on later slides. Okay, the DB recovery is also available by data file and a read log file. Like I said before, for the memory data, we provide something called checkpoint image file stored in a disk layer, which is also used for database recovery. The memory data is treated same way as a disk. That memory data also uses data file as well, the checkpoint image file, okay, and also reader log file. Both the memory data and this data are recorded together. So the reader log file is used as recovery for both of memory and a disk. Okay, for deadlock detection is the situation where 2 or more statements are competing for the lock. That is when one statement is waiting for another statement to release the lock, but they are all in waiting state. This state is said to be a deadlock. So what Altibase HTTP does is that Altibase HTTP automatically detects a situation, and once it is detected, Altibase HTTP actually rollbacks the last transaction that is waiting for the lock and terminates the related session. But whereas in typical DBMS, it rollbacks the statement that is holding a lock. Okay, so it is difference between waiting for the lock and holding a lock. Okay, log anchor file. Okay, this is like a control file in Oracle. It contains all the DB info, such as information about location, a reader log file, data file, checkpoint image file that is represented in time. It also contains the information about table spaces and other extra files such as boot file, message file, property file. Okay, this log anchor file has 3 copies, 0, 1, and 2. Okay, for the backup, that is also mainly for the recovery. Okay, for online log file, we provide reader log file sequentially, which means that the new log files are created every time the log file is filled up. That you might worry about the disk gets full as unlimited number of log files are kept created, but when checkpoint is executed, the log file is deleted. The archive log file is backup file or reader log file. Okay, before I talk about archive log file, let me talk about the database mode first. There are 2 different types of database mode. First one is called archive mode. The second one is called non-archive mode. So in archive mode, the log file is archived to archive directory whenever the log file is filled up. So the log file that is archived to archive directory is called archive log file. They are located in a directory called arch, A-R-C-H. Okay. The undo table space, this is under the sys user. And this table space is automatically created when DB starts up. So this undo table space contains previous images of data. So when a data is updated, the new version is created. And its old version is stored into undo table space. This image is used when rollbacking the statement to delete the new image and retrieve the old image. This table space is used to support MVC's in place, which is the management of multi-version of records existing in disk tables. Okay, there are a lot of system table spaces. So when there's a sys in front of the name, okay, when there's a sys in front of the name, that means the table space belongs to the sys user, and they are created when DB starts up. There are a lot of them, but three mains are sys tbs mem dictionary, which contains all the dictionary information such as meta tables. Sys tbs mem data contains all the memory table information, and sys tbs disk data contains all the disk table information. Okay. The temporary table space, this table space can be created by user, and it is also created by system as well. The temporary table space contains information about temporary tables and indexes which are created when queries are processed. The memory table space. When you create memory tables, they are stored in a memory table space. This table space can be defined by user as well. The volatile table space. I think you guys never heard of this table space before. This table space is used for maximum performance of the memory. Okay? The performance of this table space is relatively fast because it has no disk-related components such as checkpoint image files and so on. So there's no disk input and output. So when a user wants to process the data with maximum speed of performance, they can move the data from memory table or disk table to volatile table space and process them. But because this table space only resides in memory, that means when the system goes down, this table space is automatically deleted. So you need to remember that as well. Okay. This volatile table space can also be defined by user. Okay, you guys' favorite, the disk table space can also be defined by user as well.